OSPF, we have quad 2/32 and quad 3/32. Then in the router 2, let me to show you trace route quad 3. Okay, for example, trace route quad 3 with the source of loopback 0 directly to the router 3. Everything is working correctly. Because of that, we can use the network type of broadcast. Here we don't have any problem. The next network type is the non-broadcast. You know that in non-broadcast everything is same with the broadcast, only we should configure the neighbors with static neighbor command. Okay, static neighborship. Okay, if you want you can use it. Let me to configure it. Look at here, IP OSPF network is non-broadcast. Don't forget, again, you should configure the router 1 or the NHS as the DR with the IP OSPF priority 0. IP OSPF network non-broadcast here, and also here IP OSPF network and non-broadcast. When you are configuring non-broadcast, you should configure neighbor statement. Neighbor in the router 1 is the router 2, 192.168.123.2, and also neighbor is 192.168.123.1 or 3. In the router 2, we should configure again neighbor 192.168.123.1, and also in the router 3, neighbor is the 192.168.123.1. That's it. Let me to show you. In the router 1, okay, this is the router 1, conf-t, interface tunnel 0, we can use the IP OSPF network non-broadcast. Then over the router OSPF 1, here we should configure neighbor statement 192.168.123.2 and also 3. In the router 2, let me to show you conf-t, interface tunnel 0, okay, IP OSPF network, for example, non-broadcast. Then router OSPF 1, the neighbor is 192.168.123.1, and then in the router 3, conf-t, router OSPF 1, first the neighbor is 192, okay, 168.123.1, and also here we should, under the interface tunnel 0, we should configure IP OSPF network non-broadcast. Look at here, router OSPF 1, neighbor 192.168.123.1. So easy. Okay, let me to show you what is happening. Again, in the router 1, we can use show IP OSPF neighbor. The state is attempt. You know that here we should wait a little more. Okay, after we see the state of full, we will have neighborship, and this means that now after that time we can send our updates or LSAs to the other routers. This is because of the static neighborship. In the show interface tunnel 0 or show IP OSPF interface tunnel 0, you can see the hello time in this state, in this type of network type, or the for example static neighborship is 30 seconds instead of the 10 seconds in the dynamic neighborship. Because of that, we should wait a little more. Actually, we can say it is not necessary to configuring the non-broadcast. You can configure it, and I will show you that this is working. But the broadcast is better choice in compare with the non-broadcast. Only you should use the non-broadcast when for any reason we cannot use the dynamic neighborship. Because of that, it is necessary to configuring the neighbors statically. Okay, here in the show IP OSPF neighbor, again now we should wait. You know that first we should wait for the hello time. After that, we should wait for the DR and BDR election. Again, this takes time. Look at here, about the hello time we have 30 seconds. About the wait time we have 120 seconds. Now show IP OSPF can show us we have neighborship. Also in the router 2, look at here, we don't have any problem. Show IP OSPF neighbor. Show IP OSPF neighbor, we have neighborship, and show IP route OSPF can show us we have learned quad 1 and quad 3 without any problem. In the router 3 also we have similar conditions. Show IP route OSPF. Look at here, show IP route OSPF, we have received quad 1 and quad 2. Because of that, you can use ping quad 3 with the source of loopback 0. It is working. Okay, it is possible to use the non-broadcast, but it is not recommended. Maybe in some rarely cases you need to use non-broadcast option. Now let me to talk about the next option. The next option is the point to point, okay, or point to multipoint, and after that the point to multipoint non-broadcast. Point to multi-point non-broadcast. Both of them are not efficient or are not acceptable for the DMVPN phase 2. Why? Because in point to multipoint and in point to multipoint non-broadcast, we are learning the update of the quad 3 from the router 1, and the next stop is router 1. Actually, we cannot send traffic directly to the router 3. Let me to show you here. We should for the point to multipoint, I want to configure this point to multipoint. You know that we should remove the neighbor statement. We don't need neighbor statement. Okay. After that, about the network type, we are configuring the IP OSPF network. Okay. Point to multipoint. And here we don't have DR and BDR. Point to multipoint. Okay. Let me to remove the priority command. And only we are configuring the network type as the point to multipoint. That's it. And we don't have priority command because we don't have DR and BDR election. Let me to show you what is happening. In the router 1, starting from the router 1, router OSPF 1, no neighbor 192.168.123, 2 and 3. That's it. Interface tunnel 0, IP OSPF network, point to multipoint, no IP OSPF priority. That's it. This is the configuration of R1. Then R2. First, under the router OSPF 1, no, we should remove the neighbor statement, no neighbor 192.168.123.1. Then interface tunnel 0, no, first IP OSPF, okay, network point to multipoint, and no IP OSPF priority. That's it. In the router 3 also, let me to go to the router OSPF 1, okay, no neighbor 192.168.123.1, interface tunnel 0, IP, okay, IP OSPF network point to multipoint, and no IP OSPF priority. That's it. Now let me to show you what is happening. In the router 1, show IP OSPF neighbor can show us we have two neighborship with the router 2 and router 3. Then in the router 2, show IP OSPF neighbor, we have neighborship with the router 1, and also in the router 3, show IP OSPF neighbor, we have neighborship with the router 1. But in the router 1 first, let me to show you show IP root OSPF. We have quad 2 and quad 3. It is okay. In the router 2, show IP OSPF neighbor. We have show IP root OSPF. We have quad 1 and quad 3, but both of them, okay, were learned from the router 1. And this is not good for the, for example, DMVPN phase 2, and we cannot change it. In the router 3 also, show, let me to show you, show IP root OSPF. Actually, the traffic is going to the router 1. Look at here, trace route. Then trace route, for example, quad 3 with the source of loopback 0. Traffic is going to router 1 and then to router 3. Actually, we can say we cannot use the point to multipoint network type in the OSPF when we have DMVPN phase 2, and also point-to-point non-broadcast, okay? Only we can use broadcast network type and non-broadcast network type, and the broadcast is the most efficient network type. You know that in DMVPN phase 1 we had configured, okay, the OSPF with the broadcast, non-broadcast, point to multipoint, and point to multipoint non-broadcast. But in DMVPN phase 2 we can use only broadcast and non-broadcast. The broadcast is the best method. Let me to review first about the point to point. Forget about it. This is not going to work since we use multipoint GRE interface. Then broadcast, your best choice. Automatic neighbor discovery and correct next hop address. Make sure that the spoke router can't become DR or BDR. Then non-broadcast, similar to broadcast, but you have to configure static neighbors. Then point to multipoint. Don't use this for DMVPN phase 2 since the next hop address is changed by the hub. You won't have direct spoke to spoke communication. And point to multipoint non-broadcast, same story as point to multipoint, but you also have to configure static, for example, neighbors. Because of that, the best method in the best network type in the DMVPN phase 2 about the OSPF is the broadcast. All right, in this video, we have learned about the DMVPN phase 2 and also some other things related to the DMVPN, okay? And here, let me to show you the status in the router 1, show DMVPN. We have for example, 2 tunnel here, as you can see, peer in